In Chapter 9, we're going to learn how to describing data through tables and graphs. So the second step of statistics is organizing your data. So in Chapter 8, we learn how to collect data. Now we're on to organizing data. So when we organize data, we're going to organize into a table or a chart. Let's start with tables. So a frequency table. So this is how you construct frequency table. Now, if your data is categorical, here it is. All right, so we've done this before. It's called tally. All right, so we have the blue, green, and red, and then we just say frequency means how often these occurred. So if you look at these, 1, 2, 3, 4, 5. There's 5 blues, 4 greens, 5 red. Now to find relative frequency, it means to, instead of just how many times they occur, give me a percent. So in this case, blue showed up 35.7%. Now, how do I get this number? You take your frequency divided by the total frequency. So when you add these up, there are 14 numbers. So blue is 5 out of 14. That's how we get these numbers, the relative frequency. Okay, bar graph. You guys seen bar graph before. It's just pretty much taking the frequency table and then graph the frequency with it. Blue is at 5, green is at 4, and red is at 5. A Pareto chart, it's a type of bar graph, except we put in order from the highest to the lowest. So instead of putting them in order, blue, green, and red, or blue and reds are a lot higher than green, so we're gonna put them in the order of the height. That's a Pareto. Now we sing pie chart. That's another way to do this. Now these numbers, how we get these percents? These numbers are coming from the relative frequency. So these, change these into percents, then you have what we call the pie chart. Right, now remember, when you do a pie chart, you want to try to approximate the area so where it makes sense. 35, these are all about a third of the pie. Remember, the whole thing has to be 100%. Pictogram, that's another way of displaying data. Sometimes we see this in a newspaper article, so right away we can see the managers earning a lot more than the workers. You can say double, you can say triple. I mean, it's visual, okay, but it's not very informative. We only know the manager earned more than a worker, but we can always say about twice, about 3 times. Some people might even say that. So it's hard to tell exact number, but we do just know manager works definitely have more than worker. Now, some problem with representing graphing of the data. Like, look at this graph right here. Okay, blue, red, and green should be the same size. Remember from the previous example where it's kind of hard to tell, but if you download the original notes from my open math, then you'll see these label a little better. So make sure 30%, 35%, 33%. I mean, they all should be about the same size. Shouldn't be a big difference. And we add up all the percents, need to be equal to 100%. Okay, if it's not, then it's not correct. Another problem is if you look at these two charts, very deceiving. Looks like this one has a lot higher, a lot more people, or a lot more subjects, and a lot more data, which is not true. If you look the scale, these are all up to, like, this number right here is actually 2,000. This number up here, I mean, if you look, it looks, even though it looks a lot taller, but look at the scale on the side. So in order to compare something and get two different set of data, you need to make sure all label has to be the same scale. Otherwise, it's very deceiving. Okay. Now, quantitative data. How about data that's in numbers? Like, for example, so we can do the same thing with tally, like what we did before with the colors. So if you look at these, we have 85, 98, 100, 110, 115, 138. There are 6 different type of data, number data in here. We do the same thing. We find the frequency, how many 85s, how many 98s, how many hundreds, and we do the same thing with relative frequency. You add all the frequency up, you get 16. So to get this one, you get 4 divided by 16, 2 divided by 16. 1 divided by 16, 4 divided by 16, 3 divided by 16, and 2 divided by 16. So, same as before. Now, what histogram, and we graph something called a histogram instead of bar graph. The biggest difference between the two is bar graph is for categorical, and if you have a numerical or quantitative data, you want to use histogram, and histogram don't have space in between. Be very aware of that. Okay, it's unlike bar graph, there's spaces because numbers are continuous data. So number continuous, while categorical are very distinct or discrete. Okay, so just make sure there's no bars, no space in between bars. And you have these numbers, that's your x-axis, and frequency is the y. Now, what's more interesting is what if you have a large data set? Look at this data set here. That's a lot more than the previous one. If you take one number at a time, you're going to have a really long table. So what you want to do, instead of just, one number per entry, you want to do like a interval, like from this to that number. Okay, so we call it class interval, right? Okay, so how do I find out this interval? Okay, so the way to do it is this: you look at your data set, you take the biggest number, which is 460, minus the smallest number, and divide by 8. Now, where did I get the 8? They will preset that for you. In this particular question, they want to divide into 8 classes. Okay, so once you divide this, and then you get 40. Now, that number this is what you do with the number. So again, now our smallest number is 140. So we start at 140. Then be careful. We're not going sideways. We're building downwards first. So it means going to the next class. You're required to get 40 to get the next class. So take 140, you plus 40, plus 40, plus 40, plus 40, plus 40, plus 40, plus 40. That's how I get all those numbers. Now, how do we get this number? Now, since when we get plus 40, you get 180. So the one number before 180 is 179. So once you figure this number, you do the same thing. You keep adding 40. Then you get second set of number all the way down. Okay. Then after you do that, then you go through all this one by one and tally them. How many of the numbers that's in this original data is between 140 and 179, including 140 and 179. There's 4 numbers. Then same thing with the second one. How many is between 180 and 219? Okay, including 180 and 219. Only one number is in that, and you go all the way down to frequency. Relative frequency is the same thing. You take the frequency divided by the total frequency. Okay, now midpoint is new. I'm putting a different color here. Now midpoint is taking this 2 numbers right here, you add them up, divide by 2. We're going to use this in example 911 later on. Okay, this number right here, these midpoints. Okay, all right. So now once we have this frequency table, we can do a histogram as well. Okay, now the histogram is a little bit different. If you look at the number in the first set of number, 140, 180, 220, 260, those are a number that goes right here. That's how I get those numbers. And for the first bar, it go up to 4. Second one goes to 1, and then 4, so on and so forth. So first bar go up 4, and then 1 and 4. It just keep going. Now remember, histogram for quantitative data, okay, do not have spacing between them. Otherwise, you'll be doing a bar graph. Frequency polygon. Now, that's those numbers we find earlier. Okay, so to do something called frequency polygon, you take the midpoint, graph against the frequency. Okay, unlike histogram, you use these first set of numbers, which is called a lower class. You take the lower class, and then you graph against the frequency. And for polygon, frequency polygon, you take the midpoint, graph against the frequency. Okay, so you take each of the midpoint, and then its corresponding frequency, you dot them out, and you just connect them, and there's your frequency polygon.